In this question, we are asked to design a C20 concrete slab. So this design applies also when you're designing concrete columns, concrete beams. You also need to use this same procedure that I'm going to show you today. So first of all, it's a C20. What does that mean? C20, the C represents concrete. The number 20 represents the compressive strength of concrete after 28 days. We understand that concrete matures for a period of 28 days. After 28 days, it reaches its full strength. And so, for a C20 type of concrete, it means that after 28 days, this specific type of concrete will be able to withstand the capacity of 20 newtons per millimeter per square millimeter. So this is what we mean by C20. So the ratio that is used in the designing of C20 is the ratio 1 to 1.5 to 3. This simply means 1 represents cement, 1.5 represents sand or fine aggregate, and the 3 represents coarse aggregate. So this is the ratio that is used in the designing of C20 type of concrete. And so this is what we are going to design today. This slab that you're seeing on the picture, how do you design? How do you know the number of cement bags, the quantity of sand, the quantity of coarse aggregate is what we want to show you this morning. And so let's begin. First of all, we are given a ratio of 1 to 1.5. The first thing is to deduce the ratio we are given. So we are given 1 to 1.5 to 3. The first thing is to add the ratio. So we have 1 plus 1.5 plus 3. When you have that, when you have 1 plus 1.5 plus 3, which gives you 5.5. So this is 5.5. So after adding the ratio, you are going to calculate two types of volumes to the concrete. When you look at the picture you have on your screen, this concrete is still fresh. So this is what is known as wet concrete. This is wet concrete. So we're going to calculate the volume of wet concrete. Volume of wet concrete, which is equivalent to, depending on the shape of whatever you are designing. So for our slab, it has a length, it has a breadth, and it has a height. We are told, according to the question, the length, it is 3 meters times, that's 3 meters, times it has a breadth of 2.5 meters, times it has a height of 0.18 meters. So we have our volume. When we multiply that, this is the volume of wet concrete. 3 by 2.5 by 0.18. We have our volume as 1.35 cubic meters. So 1.35 cubic meters, this is the volume of wet concrete. The concrete is not yet dried, it's still fresh. We've calculated its volume. Then we are also now going to calculate the volume of dry concrete. Remember, the concrete will dry. And because of many factors, when it dries, there will be a loss of water. There will be several factors that we have to put in consideration. Then we'll add what is known as a safety factors. So the volume of dry concrete, which is equivalent to the volume of wet concrete multiplied by a safety factor. The safety factor may range from 1.54 to 1.57. So our safety factor may range from 1.54 to 1.57. So in this case, volume of dry concrete, we'll multiply it. The volume of wet concrete, which is 1.35. The volume of the shape of wet concrete, multiply it by 1.57. We're trying by all means to apply our safety to the full factor, which is 1.57. So when you multiply that, multiply by 1.57, you have 2.1 cubic meters. So this is the volume of the entire concrete together in your design. So now that you have this volume of dry concrete, you are now going to calculate the samples or the exact amount of cement. Remember the ratio 1 to 1.5 to 3. So let's consider now cement in our case. Let's consider now cement. How do you know the number of bags of cement in 2.12 cubic meters of our volume of concrete that we have calculated? So cement is represented by 1 on our ratio. 1 over the total that we calculated was 1.15. If I remember very well, it was 5.5, sorry. 1 over 5.5 multiplied by the volume that we have calculated, including the safety factor. So it would be 1 over 5.5 multiplied by 1 over that multiplied by 2.12. So we do that, then we do the math. So it gives us 0.39 cubic meters. So this is the volume. This is the volume of our concrete this is the amount of cement, sorry. This is the amount of cement that is included in that volume of dry concrete that we have we have calculated. But our aim is to know how many bags of cement are we going to use. We understand, because we have studied as engineers, that 1 cubic meter is equivalent to exactly an exact amount of 1,440 kgs of cement. Okay. Now we say, how about 0.39 cubic meters of cement? How many kilograms of cement is it going to give us? We use this ratio and we cross multiply. So we have our x cubic meter is equivalent to 0.39 multiplied by 1,440 kgs. When we reach this point, after we multiply our 0.39 multiplied by 1,440 kgs, it gives us exactly how many kgs? It gives us exactly 561.6 kilograms. So this is the quantity of cement that would be required for that volume of concrete that we calculated, which was what? Which was 2.12 cubic meter for our slab. But this just gives us kgs. Then we need to know now how many bags of cement are we going to require. We know exactly that one bag of cement is equivalent to 50 kilograms. How about for 561.6 kilograms? How many bags? X bags. What do? We cross multiply. And so we have X number of bags, unknown bags, which will lead us to 561.6 divided by 50 kgs. So how many bags? It gives us exactly, we do the division, 561.6 divided by 50 kilograms, which gives us exactly 11.232 bags of cement. So to be on the safe side, we can just round it off to 12 bags of cement. So 12 bags of cement would do for our slab, which is 2.12 cubic meters. Now that we are done with the cement, we go to the sand, the volume of sand. We go back to our ratio. Remember, now we're dealing with sand. We go back to our ratio. Our ratio was 1 for cement, 1.5 for sand, and 3 for coarse aggregate. So in case of sand, it's 1.5 over 5.5 when we added the ratio multiplied by the volume that we calculated, the entire volume that we calculated, which was 2.12, which is 2.12. Okay. When we do the multiplication, it gives us 1.5 divided by 5.5, multiply it by 2.12. So we have 0.58 cubic meters. So this is the volume in that 2.12. This is the volume of the sand that will be required for our concrete slab. But want to talk of in terms of kgs, so that we are able to know, because sand, normally when you're purchasing sand, you buy it in form of in quantities. So we need to quantify our sand. We know, because we are engineers, that 1 cubic meter, for 1 cubic meter, we have exactly 600 kgs of sand. For a concrete of 1 cubic meter, about 1600 kgs would suffice. How about 0.58 cubic meters? What would be the quantity of sand? We do not know. So we do our mathematics by crossing multiplication. So we have our x, a known quantity of sand, is equivalent to 1600, or 0.58 multiplied by 1600. So this gives us how much? When you multiply 0.58 multiplied by 1600, we have exactly 928 kgs. So for our slab of volume 2.12 cubic meters, about 928 kilograms of sand would suffice. Okay, that would suffice. And so you can order that, you can round it off to a ton, and for safety we'll just round it off to a ton, which is about 1000 kgs. For me, I would just round it off to a ton, but at least it gives you an approximate value, or safety things that we need to put in consideration as we are transporting the sand. So we are remaining with the last part, which is cost aggregate. For our cost aggregate, we go back to our ratio. Remember our ratio for our C20 was 1 to 1.5 to 3. In this case, it would be 3 over 5.5 multiplied by 2.12. Remember, then after we do the same mathematics. 3 divided by 3 divided by 5.5 multiplied by 2.12, and we have our 1.16 there cubic meter. So this is the volume of the cost aggregate in our 2.12 of our concrete slab, that volume of dry concrete. And so when we reach here, sorry for that, when we reach here, we apply the same method that we applied, in anticipation that 1 cubic meter, because we studied as engineers, 1 cubic meter of cost aggregate is about 1800 kgs. So these are ratios that should be at the back of our minds as engineers, which we should understand. And so x kgs, we do the cross multiplication as usual, and so we have 1.16 multiplying it by 1800, okay, which gives us about 2.09 kgs. Okay, sorry about that. This gives us approximately about 2000. This gives us 2088 kgs. Okay, so now we know for our C20 of the ratio 1 to 1.5 to 3, we'll need cost aggregate. Remember that it is cement, sand, and cost aggregate. For our cost aggregate, we'll need about 2 tons, which is about 2088 kilograms of our cost aggregate. And for our sand, we need about 1 ton, or 928, and for our bags, number of bags, we need about 12 bags of cement. So we need 12 bags of cement, and we need about 928 kgs